Talk, damn you. Hello, LA. I said, hello, LA. Oh, come on. One more time. Hello, LA. Oh, gosh. That was pathetic. Okay, we're gonna have to fix that. We have to fix that. Let me get everybody stand up. Come on, it's the end of the day. We're all a bit tired. If you just said hello a little bit better, we wouldn't be doing this. Okay, now everybody reach arms up to the sky. There you go. Very nice. Some twists. There you go. Doesn't that feel good? We got a little back stretch in there. Oh, excellent. Okay, now stay standing. So I am Mark Bates. You can follow me on the Twitters. I highly recommend you do. Lots of really useful comments there. I am the author of 3 books: Distributed Programming Ruby, Programming in CoffeeScript, and Conquering the Command Line, written on Michael Hartle's framework that he wrote, his platform. And I have a couple copies of that book, actually, some PDF copies to give away. So a couple lucky folks in the audience will learn all about the command line. This is what it looks like when you win one. You get all excited and just, yeah. I'm also a voice behind a site called metacast.tv, which covers Ruby and JavaScript and Go and all sorts of fun things. And if you use this coupon code, you get your first month free. So if you're interested in Go, there's a couple screencasts up there that you can learn about for free. So, okay, so like I said, we're going to talk about Go here. And I know you're saying to yourself, Mark, this is a Ruby conference, right? And here we are, we're talking about Go. Well, I've been doing a lot of traveling over the past couple of years, and it's quite common at Ruby conferences to see a bunch of other languages being talked about. And these are just a few of them. We've heard a couple today. We've heard Node today. I'm sure we've heard other ones here, but Scala is a big one. Elixir, you hear about that one a lot. So why are we talking about these things? Why are we talking about languages that aren't Ruby at a Ruby conference? And to answer that question, I'm going to go back about 18 years to 1996.
My legs hurt.
So, what do you want me to do about it? So I'm going to go back to about 1996, to when I was a freshman in college. And when I was a freshman in college, I was there the very first day. A little background here, I actually have a degree in music. And stop, you two, guy in the GitHub shirt, GitHub hoodie, and you both get copies of the book. Oh, and you in behind there, I didn't see you there. The 3 of you come see me afterwards, and we'll get you hooked up with those copies. See, Simon didn't say sit down. Oh, and I didn't say it again, so you guys lost out on the copies. Oh, no. No, I'm just kidding. But definitely come see me afterwards. That'd be really mean, wouldn't it? You guys want a book? Oh, I didn't say Simon Says. Anyway, so I was a freshman in college, and I went to school in England. A little background, I have a degree in music. And I was there, and the first day, one of the founders of the school, a guy named Mark Featherstone Whitty, very English name if there ever was one, was talking about the ethos and the principle of the school. What were we going to learn and how we were going to achieve it over the 3 years of our education. And doing this, he talked about how we had to interact with the other disciplines in the school in order to graduate, in order to pass our classes. We had to work not just as musicians and play music 8 hours a day, but we had to work with dancers and actors and sound technologists in order to achieve our goals at the school. And one of the things he said really stuck with me, and it's stuck with me to this day. And he said, art isn't created in a vacuum. And I would say that neither is software. Like good art, you need to take in influences from the outside. You need to understand what other people are doing in order to make your code better and to improve the quality of the application you're writing and to bring in these new and interesting ideas. And you need to be polyglot. That was mentioned earlier today. I'm trying to remember which talk it was, but it really is important to be a polyglot programmer. If you were a songwriter, imagine how terrible the Beatles would be if they never listened to Buddy Holly or Elvis Presley or the blues or Baroque classical music or any other numbers of influences that the Beatles listened to in order to write their songs. You would not have Sgt. Pepper had the Beatles not listened to music that was not in their style of music. So I would argue that as a developer, you need to do the same thing. You need to write stuff in a style that is not your own and to learn what's out there. And so today we're going to do that, and we're going to use Go as that language. We're going to talk a little bit about what Go is, where Go came from. We're going to take a quick overview of the Go language, very, very quick. And then we're going to end it on looking at tools that are similar to what we have here in the Ruby world. So that hopefully if you decide, I'm going to write an app in Go, or, oh, geez, my company could really benefit from using Go for a part of what it does, then you have an idea of where to start, and you don't have to kind of do all this research yourself. So what is Go? Well, Go comes from this little startup up in Mountain View. And, they're trying, people. They're really trying. They need your support. And so this little company, this little struggling startup, the search engine that could, if you will, apparently, I read this article recently on Forbes that said, just out of curiosity, how much traffic do you think Google is responsible for? Just shout out some numbers. What percentage of internet traffic? 100%. Thanks. No, it is not 100%. It's significantly lower, but not by much. So according to Forbes, that number is 40% of the internet. That's a lot of traffic. Who here can match that number in their application? Anybody? Anybody doing 40%? 39%. Anybody doing 39%? I'll take 25%. Anybody doing 20%? No, I didn't think so. If we took all of the traffic we are responsible for in this room, our yearly traffic usage, combine it all together, I would be hard-pressed to imagine we'd hit an hour of Google's. Right? They are on a level of scale that no one in this room is most likely ever going to be at unless you go work at Google. Right? It's just that much traffic. So when a company that is responsible for 40% of the internet says, we have come up with a language to solve our scalability issues, do you think it's worth listening to? Do you think it's worth the investigation? Because I certainly do. They are having, so we are having scalability issues now that they had 10 years ago. Right. So just a quick little pro tip, by the way, if you do try to Google for Go, use Golang, because the company that is known for its searchability came up with the most un-SEOable name ever. They might as well call it A. Oh, I'm using A. You guys using A? Even R is more searchable than Go. You can search for R better than you can with Go. So use Golang. Okay, so what is Golang? Well, Go is a compiled language, which I know strikes fear in the heart of us dynamic scripting language people, but it is compiled. It is statically typed, yet another thing that will get you thrown out of most Ruby conferences. Mentioning the word statically typed. It is not nearly as statically typed as, say, something like Java, but it is a statically typed language. It's garbage collected, though. We like that. And actually, it's garbage collection that works, unlike some other languages that just stop and then continue. It's cross-platform, and it is truly cross-platform. One of the nice parts about Go is when you build a Go binary, it pulls in all the third-party dependencies you need. So all the packages your app depends on and all the assets get pulled into this one binary, along with a runtime environment. What's really nice about that is I can then compile on my Mac a Windows binary, hand it to somebody on a Windows machine. I can hand it to my mother, who has no developer tools at all. She'll still screw it up, but I can hand it to her, and she could run it, and it would execute on her machine flawlessly without any other installs. That also means you can do deploys of your application by using curl, which is kind of cool. But it is cross-platform, so you can compile Go to run on all sorts of systems. It's incredibly concurrent. You've probably heard this about Go. This is kind of Go's big thing, and we'll talk about concurrency in a minute. It's also dead simple. It's a very, very straightforward language. To give you a number, does anybody know how many keywords? Now, people at lunch don't answer this question because you know. But how many keywords does C++ have? Does anybody know?
43.
No, 84. Anybody know how many Java has? 50. Very good. You were at lunch. Shh. Oh, no, you weren't. No, you weren't. You were at breakfast. Breakfast. Different meal. I'll give it to you. Okay, here's a tricky one for you. Everyone should be able to answer this one. How many does Ruby have? I'll give you a hint. It's a magic number in geek world. 42, exactly. It has 42 keywords. Go, 25. It's not bad. That's a small amount of keywords. That's, 24 keywords. That's half of Java's and almost half of Ruby's, right? That's pretty good. It also has no exceptions. Go does not do exception handling. You get an error, and you decide what you're going to do based on that error. There's no exceptions that bubble up in your application. Okay, so moving on to just talking about the basics of Go real quick here. Here's a very simple Go program. Has anybody seen Go before? Has anybody actually seen some Go code? Okay, so some people, so you have some idea. So I'll give you a quick rundown. This is the obligatory Hello World application. This is one of two applications you need to write to get your CS degree. The other one's a Fibonacci generator. And we'll be making one of those in just a minute. And a couple things you can infer from this piece of code here. There are packages. Go has the concept of packages that you put stuff into. In this particular case here, we have a main package. This is also your entry point to all Go applications, is the main package with the main function. It looks almost a bit like JavaScript to Go. It's kind of interesting. It has imports. So it's very similar to requires or import statements in other languages. One of the nice things about Go is when you go to compile it, if you import something that you're not using or you declare a variable you're not using, it'll refuse to compile and it'll throw errors at you. It'll say, oi, you tried to import the time package, you can't do that, or oi, you created an X variable and you're not using it, and it actually uses the word oi. So how many people are downloading Go right now just to see if that's true? I would totally use a language that yelled at me in like 70s punk, Cockney accents. Oi! Anyway, so it has this main function here. I'm going to print hello world. The other interesting thing about this here is actually this capital P. And it's kind of weird that I'm pointing out a particular capital letter. But Go's concept of privacy settings is really interesting. There is no private keyword. There is no public keyword. There's no protected keyword. Instead, it takes a very, very simple approach to doing your privacy based within your package. If you name a function, a constant, a type, what have you, with a capital letter, it is public. If you name it with a lowercase letter, it's private. That's it. It's either public or private. You can't call private things no matter how hard you try. You can only call public things. And it's really nice. You can very quickly look at any function and know whether it's public or private. And know whether you can use it. Okay, so concurrency. Like I said, this is one of the big things. Everybody loves concurrency in Go because it's pretty sweet. So here I have a two-function little program here. I've got a function called lift heavy stuff, right? Yep, lift heavy stuff. And you can imagine what it does. It does heavy lifting. That's why I had the comment, just in case you didn't know what that did. It does some heavy lifting. And then I have this main function here, which is going to call lift heavy things, or lift heavy stuff, sorry. And this is great, but what's going to happen is, say this takes 30 seconds to lift heavy stuff, my application is blocked on this line for 30 seconds. Right? This is a very common problem we face in the Ruby world all the time. Now, in the Go world, however, I can say, hey, you know what, Go? Run this off to the side for me here. Run this very heavy function so I can continue on. And I can do that by adding 2 characters, 3 if you count a space. I can say, Go lift heavy stuff. That's it. I've spun this off, and it's going to do it. And it's a very efficient way of spinning off. It adds like a couple kilobytes to the heap, I think, to do it. It's very, very efficient. It also uses all of the CPU processors, so all the CPUs in your machine. So in Ruby, you get that one master thread, right, that's running on that one core of your 24-core machine, right? You spin up a thread, and you still have one thread running on a 24-core machine. You run up 10 threads, you still have one real thread on a 24-core machine. In Go, you can spin up hundreds of thousands of Go routines and use all the processes and use all the system resources in your machine, all by using this one Go keyword. It does takes care of the rest for you. When it's done, it cleans up after itself. No worries. Really, really nice. And you can do this with any function, by the way. Any function. It can be any function that does anything. You can say, Go, do it, and it'll go off and do it. Right? So think of how nice it is in there. And I'll give you a good example in a second here. So here's a bit more of a complex example. And this, a really interesting, couple of interesting things we're doing here. One, we're creating anonymous functions like Go or lambdas, like JavaScript or lambdas in Ruby. But we're also creating a communications channel that our function can use. And this is a bidirectional communications channel here. So I can spin off these threads, I can spin off these Go routines and send them information. They can send me back information. And I can listen for that information, I can act upon the information that's coming back and send more information to these Go routines. And that's how we communicate with all these different Go routines. That's it. Like, that is how you communicate. There's nothing funky there. You're not putting things on thread current. If anybody's ever done stuff like that. You know, these weird actor pattern libraries that are doing this. This is baked into the language. This is not a library or a package that's added on. It is core to Go's premise. This is what Go was built for, to do exactly this sort of thing here. Super awesome. So an example of when you could use something like this, imagine this case where a user uploads an image and you want to process that image, right? We've all done this. Raise your hand if you've processed images, you've cropped them, you've scaled them. Exactly. Everybody's done it, right? So imagine now, in your controller, you get this, and you just spin off 10 Go routines, each one that does the processing simultaneously, right there in your controller. You have channels talking to all of them. Each one's communicating back when it's finishing. You've got a WebSocket talking back to your front end, talking to your JavaScript application that's saying, oh, the first one's finished, the ninth one's finished, the third one's finished, the fourth one's finished, the second one's finished, the eighth one's finished. Oh, you're 100% done. Redirect you to your gallery page. All right? And you can do that just by doing this sort of stuff here. Really slick. It is pretty super cool. Okay, so speed. I said Go is very fast, and I think people have heard that. Here is that Fibonacci generator in Go, because most websites run on the power of Fibonacci generators. Why do we use this as a benchmark for anything? Who has ever realistically written a Fibonacci generator in the real world? Like, honey, I deployed a Fibonacci generator today. The CEO comes in. How's that Fibonacci generator coming, Mary? It's coming along. I'm almost there. Just got to run a few more tests. But anyway, so here's my Fibonacci generator in Go. And here's the admittedly nicer to look at Ruby version. But when we run these rather arbitrary benchmarks, we can see that Go comes in at 0.005 seconds to run, and Ruby's 0.38 seconds. Right? So Go is, 7 times faster in this particular case? Those numbers start really adding up as you move forward, especially when you throw in the concurrency and you're processing 100,000 things simultaneously on one machine. Talk about getting the most of your free Heroku Dyno. Go, baby. Go will do it for you. So definitely very fast. So duck typing, I actually wanted to change this slide to it be titled interfaces, but I think duck typing is actually an interesting topic because it's something that's so near and dear to our hearts as Go developers, as Ruby developers. Yeeks. Wow, I've converted you all already. We're all Go developers. Right? We all love throwing any arbitrary thing at a method, and as long as it has that function, it'll run just fine, right? So Go is statically typed. You do have to say in a Go program, I want something of type string, or I want something of type X, Y, or Z to come into this function, and then I could call things on it. Well, Go lets you kind of get away with duck typing a little bit by the way it handles interfaces. So in Java, because my experience before Ruby in the early 2000s was Java-based, that's what I always equate things to. So in Java, you have explicit interface declarations. You say, I have an interface, it requires these functions, and then in my class, I'm going to implement this interface explicitly and then define those things. Go has an implicit interface relationship. So what that means is if you define an interface that requires X, Y, and Z functions, if your struct happens to also have X, Y, and Z functions on it, you implement that interface. It's as simple as that. So anything that implements those functions automatically implements those interfaces. And everything implements the empty interface. So if you really wanted to get crazy, you could say, my function takes an empty interface, which is the equivalent of saying, I take object in something like Java or Ruby, right? I'll take any object you throw at me, and it'll work. But here's an example here. I've got a greeter interface up here, and it says I want to say hello function. I've got a talk method here, which takes a greeter. I've got a function, a foo struct that implements a say hello function, and the same thing with bar struct. And then I can call both of them. They're both implementing that interface. This code will run. This is executable code. All right, I didn't have to go and explicitly implement it. I can just do it. So this is really, really nice pattern to have. Okay, so on to the stuff that's probably useful for you as Rubyists coming to Go, right? The things that we use every day that we need. So package management, I'm going to start there, right? Because Go lets you use third-party packages, thankfully, because it wouldn't be much of a language if you couldn't. They offer you Go Get, which is kind of nice. It's a thin little wrapper around Git clone. It's not that useful, to be perfectly honest. It's nice to fetch stuff from a repo without having to do Git clone. You just do Go Get in the package. But it doesn't do package management for you. It puts everything kind of in a central location. You can't lock down specific revisions, yada, yada, yada. I just found out about this today, actually, at lunch. The Go package manager is basically bundler for Go. So you have a Go depth file, I think, and it lets you do all those nice things. So definitely would want to check out this package here and use that for managing dependencies. I've also heard people using like make files and stuff. This seems like a much cleaner way of doing it. So testing. Testing is important to everybody, or it's important to Rubyists. It is not important to everybody, I can tell you. There are definitely some communities out there that don't do testing at all. JavaScript. And honestly, man, I give so many JavaScript testing talks, and just no one raises their hand, and it's so sad. Test your JavaScript. If you take one thing away, test your JavaScript. And if you don't, I will find you. Anyway, so Go also takes testing very, very seriously. This is a Go test here. I'm testing a package called calculator. My calculator package has add functions, remove functions. Add, subtract, whatever. This is very simple. It's kind of test unit style in that you import a testing package, you create a function that's named a particular way, in this case test, and then the name of the function, so test add. You call the function, you check to make sure it does what you think it does, otherwise you kind of add an error to the test, and that all gets printed off at the very end. Very simple, very easy to use. It's just straight Go, which is kind of nice. If you'd like something a little more mini-test-ish or RSpec-ish, Pivotal Labs, College Pivotal, right? There should be like 18 Pivotal people here today, I think. 20 of them gave talks, I think. I think half of today's talks are brought to you by Pivotal, which is kind of interesting. But anyway, they released this great little framework here called Ginkgo. Hard to say, but awesome to use. And it looks a little bit like this. You can do describe blocks, you can do it blocks, a little bit more, you can do expect this to equal, that sort of thing. It's nice. I like it. I think it's just a little, I don't know. It's more used to what I'm used to as a Rubyist, right? The plain one is nice, the one that Go gives you. This is nice too if you come from that Ruby world or you like that behavior-driven kind of style to it here. A couple real quick things to note here. Actually, these little dots up here in the imports are there for a reason. So I remember I was creating this slide, and I'm like, where the hell these little dots come from? Even though I had written this code, by the way. I thought it was part of like my copying process. I deleted them, and I ran the code. I'm like, oh, they don't work. So when you import stuff in Go, this is kind of an interesting little fact. I told you earlier that if you import something and you don't use it, Go yells at you, right? So you have a couple other options you can do. You can put an underscore in front of the import, which says, import this thing, but don't yell at me if I don't use it. And strangely enough, there are use cases for that, particularly around databases for some reason. The other one is this little dot here, where you say, if I put a period in front of this, to import what's inside that package to this current package. So that's why I can just call describe and not ginkgo.describe, or why I can call add and not calculator.add. So it's kind of an interesting way. If you notice, everything is kind of prefaced with the package name, so you can get around that if you use those dots if you really want to. It's not kind of the typical way you do things, and you wouldn't write a lot of programs like that, but testing is certainly a nice thing to do that with. Okay, so the web, right? Who here writes web applications? Anybody? Anybody? A few people. Have you guys ever heard of Rails? I've heard good things. So Go, surprisingly, has a great net HTTP library built right in here. This is an example of kind of a hello world Go web application. So one thing I will say about this is the equivalent, by the way, of doing WebBrick. Right? This is the kind of WebBrick-ish package inside of Go. Now, who here knows WebBrick? Everybody know WebBrick? Okay, it's a built-in server that comes with Ruby. Who here would deploy WebBrick to production? Okay, you've done that. You are a braver man than I, my friend. Okay, WebBrick is not production ready. Do not throw it into production. You might be tempted to, but do not. Whereas this actually is production ready. This is so battle hardened and DDoS proofed that Google uses this to power downloads, the download site for Google. So when you go to dl.google.com, you download Chrome, you download Android apps, anything you download from Google runs through this library. Right? That tells you something. Again, I would never deploy WebBrick, but if Google's using this to power their downloads, it's got to be good. It's got to be powerful, and it's got to be fast. If this sort of style, this kind of raw style here doesn't work for you, highly recommend the Martini package. Right? Martini by Code Gangsta. Jeremy Sands, is that how you pronounce his name? He's a Rubyist, gone gopher. I'm not quite sure what they call it. They call themselves Golangists. But anyway, it is a Sinatra-esque framework because every language has to have a version of Sinatra. Even Ruby's got like 30 versions of Sinatra. It's amazing. But it's really nice. It really kind of cleans things up for you. It's got a great contrib package that does things like method override and session management and rendering and all sorts of stuff. Really, really clean, really nice. And it fully interacts with the net HTTP library. So if you pull in other packages, it doesn't kind of clobber all that. It still works. So you can kind of use things together. And someone at lunch today asked me about templating, and I didn't put a slide up here, but I probably should. So Go has a really nice templating library built in, very handlebars-esque. But one of the interesting things about it is it does context-aware escaping. So let's say, for example, you pass the template a struct, and inside of a script tag inside that template, you want to put the struct. Go will take that and convert that to a JSON object and print it out as a JSON object, right? But if you put, say you're in an href tag and you put a string, you insert a string into a URL field in the href tag, or in the href on the href tag, it'll URL escape it, right? So it knows where you are in the HTML and figures out your proper way to escape whatever it is you're trying to do there. Just pretty nice, pretty slick. And you can also, and the other thing is kind of interesting, you can only pass one thing to your template. So in Rails, you can create all these different instance variables and they're all available to you in your template, and then your views end up looking like shit because you're doing 100 different things in there, right? Go says, no, you got one thing. Give me one thing to pass in. So you really have to think about what it is you're going to pass in. Right? And so you end up with these templates that really do just one thing, which is what they're supposed to do. So that's really, really nice. So databases, Go has drivers for all your modern, exciting databases, even Mongo, if you consider that a database. Or just a storage to put stuff you don't care about. I have to, just quick off topic. So I got an email from Recruiter the other day, and because it's just classic. And it was for a senior MongoDB architect job. And I just had what the hell is that? Like, what is a senior MongoDB architect? Are we not all senior MongoDB architects? Just by installing it, you instantly have that? Who is like, this is somebody's career? Like, this is a business card somebody has printed up? Like, oh, I'm a senior Mongo architect. Yeah, well, I keep losing all my shit. Well, yeah, we know. We're aware. We're working on it. Anyway, sorry, I didn't mean to go off on a tangent there, but it's so crazy. Anyway, so there are, like I said, there are drivers for everything. The Go documentation actually has a wiki page that lists all the drivers. The Postgres driver, there's a couple of them. The PQ one is fantastic. Really stable, really, really fast, really recommended. There are a couple other frameworks you can put on top of that. One I think that should be included in the standard library is called SQLX here. And this just adds a little, few extra sprinkles of goodness on top of the SQL package that Go has. In particular, it lets you map result sets to structs. So you can work with them really, really nicely. So if you do anything in Go, any sort of database stuff, instantly add this to your project and use it. Is phenomenal. It uses all the same method calls that the Go built-in one does, but adds a couple extra sprinkles on top. Well worth it. If you want something more ORM-ish, Gorp will do it for you here. Good old raisins and peanuts. or Go relational persistence, I think is what they were trying to go for there. But all I can think of is camping and hiking when I was a kid. And that gives you a bit more things. It's got like migrations and other type things. It's a little heavy-handed and over the top for me, to be perfectly honest, because Go is so simple that when you start using something like this, you feel like, oh, why am I doing this? It's like when you start using active record with Sinatra. You're like, should I be doing this? Something just seems wrong here. But it's nice. And so if you want, like, I would recommend using like the migrations from Gorp with the SQLX package. And you get kind of a nice best of both worlds thing going on there. And then finally, there's Jet. Jet kind of sits between the two of them. The guy who wrote Jet actually had a really good package called Hood. And that was very active record-esque, had wheres and all sorts of stuff, and he stopped maintaining it in favor of Jet, which kind of bummed me out because it was actually pretty nice. But check it out, it's kind of interesting. So workers, if after all this you feel you still need background workers because Go routines aren't fast enough for you, I would recommend the Go Worker library. And the interesting thing about Go Worker is it consumes rescue jobs. Oh, now I've got your attention. So you can use the rescue library in your Rails app to throw jobs into Redis and then have them pulled out using Go and worked on with Go. Because as everybody knows, rescue, not the fastest thing in the world. It's nice. Sidekick is significantly better, let's be honest. But Go Worker claims to be 10 to 100,000 times faster. I am not verifying the tenacity of such claims. I am just merely the guy up here telling you that this is a good package. Again, those numbers seem awfully high. I think they're processing the 40% of the internet that Google is doing with these 100,000 times here. But it's definitely significantly faster. So think about it. So assets, right? The asset pipeline. One of the big things I love about Rails is the asset pipeline. I'm a big CoffeeScript guy. If you didn't notice, I wrote a book on CoffeeScript, really big into it. So assets are a big thing. I love the compilation of CoffeeScript into JS and then into one big file and concatenating it. And what I've been doing up until today is actually shelling out to Ruby. I shell out to sprockets in development mode. I shell out to sprockets. It does all the compiling, renders the stuff back to the screen. And then in production, I compile it all as the JS and ship it. After today, however, I think I'm definitely going to switch to lineman. So that looked pretty awesome. So good job, Searles. Very nice. Very excited. I can't wait to see the lineman Go package. I'm putting you on the spot now. There's got to be a lineman martini, rather, I want. So when should we use Go? I've extolled the virtues. I've showed you all the great packages you need to build a great web application in Go. So when should we use it? Well, CLI. First and foremost, never write any more CLI that isn't in Go. Right? One of the things I see on Stack Overflow, Reddit, the Boston RB mailing list, all sorts of places I hear this question asked all the time, how do I package up a Ruby command line app for distribution with all my dependencies and stuff, and people don't have Ruby installed, and is there a way to do it? And the answer is no, you can't. It's a real pain in the ass. Go, you get that one file. That one file I can give to my mother, and she's the most technologically inept person. I love you, Mom. Most technologically inept person I've ever met, and she could run a Go file. She could do it just by double-clicking on it. CLI, it's awesome for CLI. It's got a great command options parser built into it as well. Concurrency. If you're doing any sort of concurrency, Go is a great fit for you. Right? If you're just doing a simple document-based Basecamp-esque app, then Rails is going to work just fine. We heard that talk earlier, right? That's what Rails is great at. However, if you want to do something outside the box, you want it to be highly concurrent, right? I would say don't use Node, use Go. Go is going to be a lot faster, it's going to be a lot cooler, and all the kids are going to come want to work for you. Speed, we saw it in the world of Fibonacci, Go is king. Because like I said, all apps run the power of Fibonacci. It has a light to moderate learning curve. It's a pretty simple language. Once you learn the structure and the basic concepts, you're kind of good to go. I showed you, these slides contain like most of what you need to get going with Go. The documentation gives you the rest. It's also a great language to shell out to Ruby. I told you I was doing that with sprockets. I was shelling out and saying, can you give me this stuff and give it back to me? So if you've got these really great Ruby transformation scripts, for example, Ruby's great at stuff like transformations because it's so heavily meta-driven, right? If you have these very little scripts that do all this stuff, you can still call them from Go. Have your Go routines out there, calling on these Ruby processes, these little Ruby scripts, which are then going to use all the processes on your machine, right? As opposed to kind of this one monolithic Ruby thing, right? There's a lot of benefit of mixing both of these two worlds here. So finally, some resources. I gave you a lot of resources in the slides, and the slide deck should have been tweeted out 14 minutes and 20 seconds ago if Buffer was doing its thing. So follow me on Twitter, and you'll see this. You'll get access to the slide deck. Golang.org, great resource. Some little screencasts up there, some excellent docs. They have a book called Effective Go. It's an HTML book, but if you print the PDF, it's like 56 pages. It's really, really good. Like I said, there's some great Metacasts videos. Matter of fact, Monday's video is on SQL and Go, so if you want to learn more about SQLX, definitely check that out on Monday using your free Metacast coupon for the next month. And that is it. I think I've got some time for some questions. So who has questions? I think that's it. Thank you guys very much.